Hello guys and welcome back. So today I'm going to explain how do we find the domain of definition of some particular functions. And basically I'm going to focus on polynomial functions, rational functions, radical functions, logarithmic and exponential functions. But first of all, I'll start by a simple definition of domain of definition, in which the domain of definition is simply the set of all possible real numbers or values of, so that f of x is well defined. And basically, like we sometimes in math we have like some problems inside the real set, like which is dividing by 0 is not allowed. Under radical we are not allowed to use negative numbers. Same thing with logarithmic functions, we cannot use negative numbers. So for this reason, while studying the domain of definition, we have to make sure that this function, to remove all values of x, so that, for example, or so that the function is not well defined. So let me start first with polynomial functions. So basically polynomial functions are functions in the form of f of x, a(n) or a index n x power n plus 3 dots plus a index 2x squared plus a1x plus a power 0, and n can be any power, and usually n is the highest power, and it's called the degree of the polynomial. Like, let me give some particular examples. Like, let's say if I have f of x simply equal 3x power 2 plus 12x plus 1. Like, if you look at this function is a polynomial. The degree of this polynomial is 2 because it's the highest power. Another example, let's say g of x is equal x power 5 plus 3x squared minus 1, for example. This one is also a polynomial with degree 5 because the highest power is 5. And of course 3 is said to be, like in this example, 3 is the coefficient of x squared, 12 is the coefficient of x, and 1 is the constant part. Same thing here, 1 is the coefficient of x power 5 because it's 1x power 5, 3 is the coefficient of x squared, and negative 1 is the constant part. And usually in polynomial functions we don't have problems. Why? Because we don't have fractions, we don't have radicals, we don't have any different functions. So all what we have in polynomials is addition of monomials. For this reason, the domain of definition of polynomials is the set R, or all real numbers. So because simply we don't have problems, so the domain of definition of the polynomial functions is the real set, which is also known as by the line negative infinity plus infinity. Now, rational functions are functions that have the form f of x equal p of x over q of x. And simply I can say that p and q are polynomials, but the degree of the denominator must be bigger than 1, which means that the fraction must include x in the denominator. For this reason, guys, basically, like in math, as I said before, we are not allowed to divide by 0 in the real set. For this reason, the domain of definition here simply all possible values for x such that q of x is different than 0. Because if q of x is equal to 0, this means that f of x will not be well defined. Now let me use a very particular example for f of x. I can simply say that f of x is equal to x minus 3 over x plus 2. As you see, f of x here is a rational function because it's in the form of p of x over q of x. But all what we need to do here to make sure that x plus 2 is different than 0 because it's the denominator. So to find the domain of definition, I have to start by saying that we need x plus 2 should be different than 0, which means that x is different than negative 2, and we subtract 2 both sides, which means that all real numbers, we are allowed to use all real numbers, but except x equal negative 2. So the domain of definition will be all real numbers except negative 2. So if we need to write it as interval, it will be negative infinity till 2. Then we have to skip 2 and write union 2 to plus infinity. So this will be the domain of definition of this particular point. And as you see, usually guys, when we divide by a polynomial, we have to remove points. And for example, you will see that the interval will not include the roots of the denominator. So also guys, later on we can divide also by radicals, but this will be discussed in with radical functions, because sometimes we can divide by radical, which means that q of x can be here also a radical function or any function, but all what we need to do is to make sure that the function in the denominator different than 0. Now, radical functions are functions that have the form f of x equal radical g of x. But guys, for this function to be defined, we need the function under the radical to be positive, because we know that in real numbers or real set, we are not allowed to use negative number under the square root. So here, all what we need to do is to solve the equation first. G of x is bigger than 0. So after solving this equation, we can find the interval where the function f of x is defined. Let me try to use an example. So let's say we have the function f of x, and let me use g of x, for example, simply x plus 3. So here g of x is equal to x plus 3, because x plus 3 is the function under the radical. So all what you need to do, you need to make sure that x plus 3 is bigger than or equal to 0. Pay attention that radical 0 is defined. It follows that x is bigger than or equal negative 3, which means that the domain of definition of this function is all values for x that are bigger than negative 3. And if I want to write as interval, it will be negative 3, positive infinity. Logarithmic functions. So what do you mean by logarithmic functions? Are functions that have the form f of x equal logarithmic function with base a of g of x. In logarithmic functions, guys, the inside function should be bigger than 0, so the logarithmic function is defined. And here, this function is defined, f of x is defined if the logarithmic function here is bigger than 0. So as usual, let me do a particular example. So for example, here I can choose any function g of x. Let's say, for example, x plus 12. So all what you need to do is to make sure that x plus 12 is bigger than 0. And here, if you want to solve it, you have to say that x plus 12 bigger than 0. And pay attention, it's strictly bigger than 0. It's unlike radical. So which it follows that x strictly than negative 12. So this will be the domain of definition of this particular case. And finally, we have the exponential functions. With exponential functions, we don't have any problem, because the domain of definition will be always, all values for x are accepted. But sometimes, guys, take into consideration that sometimes, like for example, I'm using g of x. Let's say, for example, if I define f of x as e raised to power g of x. If I here, for example, as exponential function, the domain of definition is r, but still we need to study the domain of definition of a g of x. And here I'm supposing, especially in the previous examples, I suppose that the domain of a g of x is the real set. But in this case, for example, let's say if g of x is defined, always defined, so the domain of definition of exponential function is the real set. Later on, guys, I will be doing examples or particular examples about finding the domain of definition. So please keep tuned. See you later, guys. Bye bye.